Today we're going to solve our first word problems. We call them one or two number word problems because we're looking to find one or two different numbers. Personally, I call them puzzle problems because it's like solving a puzzle. To me, this is really more of a game than anything else. Let's talk about how we'll approach these problems. It'll give you a little description or a little sentence or two. First thing to do is read the sentence 2 or 3 times. 4 if you need to. Make sure you understand what you're reading and you understand what you're looking for. Once you know what you're looking for, I usually take a pen or a highlighter and underline or circle the important pieces of it. That helps me to write my equation in a couple of minutes. Then, whatever I'm looking for, that's going to be my variable. So if I'm looking for a number, then I'm going to call the number x. If I'm looking for somebody's age, then I'll call the age x. And I'll write a let statement that simply says, I'm using a variable, and this is what it stands for. Once I've done that, I write out my equation and solve the equation, and I'll come up with my answer. The last thing you should always do is ask yourself, does this answer make sense? If, for example, you're looking for someone's age, and it says they're 20,000 years old, that probably isn't quite right. The answer doesn't make sense. Or let's say you're buying an apple at Wegmans and the price comes out to be $32,000. That doesn't make sense. So you should always ask yourself, is the answer logical? Does it really make sense to me? Now, let's take a look at our first example and see how we work through problems like this. We have for our first example a simple sentence. 5 times a number decreased by 7 equals 13. And we're going to write our things just like it sounds. 5 times a number decreased by 7 equals 13. Find the number. So I'm looking for a missing number. And so the thing I'm looking for is what I'll use as my variable, x. So my let statement right here says let x represent a number. Now let's write out our equation. We have 5 times a number decreased by 7. 5 times a number decreased by 7 equals 13. So I've written my equation. Now let's go through and solve. I begin by adding 7 to each side. 5x equals 20. Divide by 5 and x equals 4. So it looks like the number is 4. Of course, I should ask myself if that answer really makes sense. Let's take a look. 5 times the number, 5 times 4, 20, decreased by 7 equals 13. Yeah, that makes a lot of sense. So it looks like this is a pretty valid answer. Again, we went through, we read the question a couple of times, made sure we knew what we were looking for. We said, okay, we want to find the number, so that's what we'll put as our variable. We wrote our let statement and then solved the equation. Let's look at another example. Example 7 says 5 less than twice a number is 25. 5 less than twice a number is 25. Okay, so 5 less than twice a number, so that'll be the first part. 5 less than twice a number is, the word is means equals, remember that, 25. And I want to find the number. So the missing number is going to be x. So x represents a number. Let's write our equation. 5 less than twice a number, 2x minus 5, is equals 25. So 2x minus 5 is 25. Now let's solve the equation. Add 5 to each side, 2x equals 30. Divide both sides by 2, x equals 15. And so it looks like my number must be 15. Let's see if it makes sense. 5 less than twice a number. So twice the number would be 30. 5 less is 25. Yes, it makes sense. So that's a pretty good example. Now, sometimes the information from one of these problems is more embedded in the problem, in the context. You actually have to read it a little more closely. And in fact, I believe on the next example, We're throwing a party. Let's take a look. Oh, we are. Emma is addressing invitation. She's having a great party. It's probably to celebrate algebra. So Emma addressed 7 invitations, which is 1 more than half the number she will send. How many will she send? Oh boy. Lots going on here. I better read it again. Emma addressed 7 invitations, which is 1 more than half the number she will send. How many will she send? Well, what I want to know is the number of invitations she's going to send. So that'll be my X. Let X represent the number of invitations that are being sent. And now let's underline the important things. 7 invitations is 1 more than half the number. 7 invitations is 1 more than half the number. There's really that one little piece of the sentence that we've been working with already. 7 is 7 equals 1 more than half the number. 1 more than half the number. And so now that I have my equation, subtract 1 from each side, and now multiply both sides by 2, X equals 12. So it looks like she'll send 12 invitations. Does that make sense? I mean, you would think you'd invite a whole lot more people to an algebra party, but maybe it's a small one. Let's check it out. 7 is 1 more than half. Well, half would be 6. 1 more would be 7. I guess it does make sense. She's having a small math party. You would think there'd be hundreds of people at this thing. People will be very jealous that they weren't invited. Should we take a look at another one? Maybe one that has 2 numbers? Let's try it. The sum of 2 numbers is 43. One number is 5 more than the other. Find the numbers. Okay, there's a lot going on here. The sum of 2 numbers is 43. So the first number plus the second number is 43. That much I got. One number is 5 more than the other. Find the numbers. So we're looking for 2 numbers. The first number we know nothing about. We'll call it X. The second number we don't know very much about. All we know is it's 5 more than the other. 5 more than the other. Well, if the first one is X, the second one is 5 more, X plus 5. So here's my first number, here's my second number. And since the sum of the 2 numbers is 43, the first number plus the second number equals 43. Now, that gives me 2x plus 5 equals 43. And I'm just simply now solving the equation. 2x is 38, so x equals 19. So my first number is 19. The second number is 5 more, 24. And so there are my numbers, 19 and 24. Once again, I'm going to ask myself, does this make sense? The sum of the 2 numbers is 43. 19 and 24, they do add up to 43. That part's good. One is 5 more than the other. 19 and 24. 24 is 5 more than 19. So it looks like the answer makes sense. There was certainly more going on in this example where we had 2 numbers and we had to sort through the information. But once you get the hang of it, it's not that bad. Let's take a look at one more example. The sum of 2 numbers is 93. Second number exceeds the first number by 15. They want us to find the numbers. We need to find 2 numbers here, the first number and the second number. The first number we'll call x. The second number is 15 larger, exceeds the first number by 15. And remember, exceeds means addition. So the second number we'll call x plus 15. It says the sum of those 2 numbers, the first number plus the second number, is 93. And so we have x plus 15 equals 93. Now, I'll simply solve this equation. I end up with x equals 39. That means my first number is 39, and my second number, which is 15 more, is 54. Does this answer make sense? Well, the sum of the two numbers is 93. 39 plus 54, yep, that's 93. That's good. The second number is 15 larger than the first. Yep, that's 15 bigger than that one. And so it looks like 39 and 54 are my numbers. I'd like to leave you with one example to try. I'm going to ask you right now to pause the video and try the final example. Come back once you're done and we'll see how you did. One number is 5 less than twice another. The sum is 121. Find the numbers. Well, we want to find two numbers, the first number and the second number. The first one is x, the second one is 5 less than twice the other, 5 less than twice the other. So 2x minus 5. Their sum is 121, so here's my equation. I get x equals 42. So here I have 42, plug in here, I get 79. It looks like my two numbers are 42 and 79. And so does that make sense? Well, let's see. The first one number is 5 less than twice another. That would be 84 minus 5. Yep, 79. That's good. The sum is 121, 79 and 42. Yep, they add up to 121. It looks like I found my numbers. Really, when you're working with any kind of a word problem or a puzzle problem, the best thing you can do is slow down and take your time. Read the problem 2 or 3 or 4 or 5 times if you have to. Make sure you know what you're looking for. Make sure you know what you're trying to find and what you have to.